Well, good evening and welcome back to the Johnson Space Center for tonight's mission status briefing after quite a day in space. With us tonight to recap the day's events are Kelly Beck, the STS-117 lead space station flight director, Keith Johnson, the STS-117 lead spacewalk officer, and Mike Suffredini, the International Space Station program manager. And we'll start off with Kelly.
Good evening. We had a really good spacewalk today. The crew just did an excellent job and we accomplished the objectives that we had planned. Keith's going to give you some more details on how the spacewalk went, but I'll just hit the highlights. First thing that we went out to do, we had Danny Olivas complete the OMS pod blanket repair that Keith will demonstrate for you with the tile board over there. While Jim Riley replaced a water vent on the lab with a hydrogen vent. And what this is going to allow is it's part of the system, the oxygen generation system, that the vent itself will allow the hydrogen byproduct to be dumped overboard, and so that we can activate that system once the software is available after this flight. The crew also completed the 2B retraction, which went very well. We were hoping to be able to finish that on the third spacewalk, and it took us a little bit longer than our normal planned 6.5-hour EVA, but we were able to get that completely retracted. Jim Riley and Danny Olivas used the techniques that we had planned pre-flight, and they had no surprises, so that went extremely well. They did a thorough inspection at the end of the retract and confirmed that it was in a good configuration so that the ground team could latch up the blanket boxes. Let's see, we did, like I said, we did go a little bit long. We went to about 8 hours of EVA time, but completed all of our objectives, so we were very satisfied with today's activities. Tomorrow, primarily, the crew is going to be preparing themselves for the 4th EVA, and that will be Pat Forrester and Steve Swanson performing that spacewalk. And I'll go ahead and hand it over to Keith at this time.
Thanks, Kelly. Let's see. The crew started off on time today. They were in good spirits, and we knew what we had to do based on the information that we sent them up yesterday on the OMS pod repair. So we had a good set of tools, we had a good set of procedures, and the crew started out the door. I brought the mock-up that you may remember seeing that John Shannon talked about a couple days ago. They spent a couple days putting all this together. We determined that we would start off pushing the blankets in place using the gloved hands. That seemed to work very well. They massaged it to make sure that we closed the gaps and that it got where it needed to go. We followed that up using the stapler. That was a surgical stapler, and we inserted about 12 staples on the lower level, and probably somewhere around 14 to 18 staples on the upper level to close the gap up. And Danny Olivas reported that the staples went in well. They pulled the pieces together, and from what we could see from the video, it really looked like a good job that he did stapling it. We followed that up using the pins that are the TPS repair pins that are there to insert SAFIL in a tile repair, and they worked very well poking through the blanket. It was a bit of a learning curve for Danny to figure out how to poke them through at the very beginning, but he did that on the good tile, or on the good blanket, to get kind of as insurance on that blanket, but also to get ready for when he repaired them on the damaged blanket later on in the EVA. We got some good video of that that hopefully we can show you here, if we can run the video. Okay, he started off on the arm. The good news is that he learned that quickly, how to GCA, drive the arm and tell the operator where he needed to go. Got up to the work site. We got some really good video of it. He took pictures with his still camera and also with his wireless video that he has on his helmet. He pushed the blanket in place. We noticed that there was some RTV sticking out, but that seemed to get pressed back in nicely when he started the stapling. And there you can see him working with the staples. They went in very well. Once that was done, he started pinning it. Here you see him putting them in the damaged blanket. They went in well. They covered the area. Our main goal was to get it between or below the outer mold line of the tiles that are in front of it. And you can see from that video that he did a very good job getting them pressed into place, and down below from that angle it looks really good. He's almost at the completion of it, and after that he rode the arm back to the lab, egressed it. At that point, Jim Riley had finished installing the lab vent, and he was having problems installing the cover, the MMOD shield. That's a micrometeoroid orbital debris shield. And the problem that he was having is that it has what are called Zeus fasteners. These are quarter-turn fasteners that we have a special tool that we insert, and it drives a latch on the back. He inserts it and rotates it. The problem is that all of these have to be very precisely placed and pushed in and held and aligned while he inserts the tool and turns it. He worked quite a while trying to get that in place, and he just couldn't get all of them latched. So when Danny got off the arm, he came over and helped out, and we still didn't get it, so we used some tethers and temporarily restrained it in that location. After that, they started up to the arm, from the shuttle arm over to the station arm, and they rode that all the way up to the 2B solar array and did the retraction, and I showed you guys this tool last time. This was a tool that Danny Olivas used. He poked on either side of the mass canister, and it worked really, really well with the coordination between the guys inside and the fluffing of the blankets. I think this one went so much smoother than the one on 12A.1, and that's thanks to all the techniques that we learned from those guys. So that was successful. We got it retracted, and after that, the guys came in, and it was a successful EVA. And that's all I have.
Thanks, Keith. Mike?
Well, good evening. I guess I would report that during the, since these folks have so aptly described what happened during the EVA, I'll talk a little bit about what was going on in IVA. While Danny and JR were outside, our Russian colleagues were busy uplinking a procedure to the crew in an attempt to bypass that sensitive circuit that I was talking to you about earlier, to see if we could prevent this constant rebooting that the computers were going through that wouldn't allow them to come up. They implemented, it was a very simple shunt that they put into, they removed the connector on the back of the computers, and they inserted a simple shunt, and the shunt allowed them to bypass this circuitry, which allowed the computers to come on. And then they went to activate. They went and activated the computers, and they went to activate the 4 that they thought were still good, and all 4 of the computers came up in the configuration that tracked each other. They kept them there for a while to ensure that it was a stable configuration. Then they shut down the computers, and they had the crew wrap them up and tape up, put tapes in locations so that the shunt would stay in place, and then put the connectors back in place. They buttoned up the area, and then the ground activated all 3 of the computers for all 3 lanes of terminal computers on both sides, both the guidance navigation control system and the command and control system. And it did exactly what they expected. It attempted to activate all 3. Because one had failed hard, it was left out of the set, and the other 2 came up. And that same thing occurred on both sides. So currently on orbit, we have 2 lanes of command and control computers and 2 lanes of the guidance, navigation, and control computers up. They've been up since, well, Danny was doing his handiwork when I saw the data indicating that they were up. So since that time, about 3:30 local, they've been up. Our Russian colleagues then activated the cooling system in the service module, which required the command and control computer in order to activate. That was necessary to begin to cool the service module down. It had warmed up a bit. We had lowered the set point in the lab in order to help cool the service module, but it was still a little warmer than they'd like, because with the computers running, you want to make sure that you cool the environment. So they successfully accomplished that, and then at that point they stood down and they want to let the computers run for a while overnight to make sure they remain stable, and then tomorrow, if everything looks well and the data indicates the computers are doing all right, then I would expect that we would slowly begin to activate the systems on board, including the attitude control systems. So our colleagues were very excited about the events. I told you, I think yesterday, or maybe it was the day before, that we would start to feel better when these things, when we went to activate them, they came up and came up together and stayed up. That would be a signature we'd expect, and one we hadn't seen in a couple of days. And so when we all saw that, it was kind of an indication that things had changed and changed for the better. So it looks like to us and our teams are going to meet early this morning to talk to our Russian colleagues about exactly what they did. But it looks to us like they were successfully able to take out of or bypass the circuitry that was sensitive to whatever the noise is that's in the system, and the circuit from our perspective looks like it's not a mandatory circuit in the computer, but that's the discussions we'll have tomorrow to see just exactly what it is we've bypassed in the system. But they do appear to be running and doing their function. And so so while we're very happy about that turn of events, we have not stopped the work we started in some of these other teams I mentioned to you earlier today. So we'll continue to work other options for attitude control like we talked about. We'll continue our assessments of the logistics and how we trade logistics if we determine we'd like our shuttle friends to stay a little longer and control the stack for us while we determine our attitude control techniques. In probably 24 to 48 hours, we'll make a determination on the health of the computers and whether or not we feel like we can rely on them, and then we will, with our shuttle friends' help, determine a departure date for our shuttle colleagues. If we feel like the computers are stable and they're back to normal, there's an advantage to us letting our shuttle colleagues leave at normal time, because we can acquire some of the oxygen that are in their tanks and fill up our tanks for future use. And so that's the trade we're trying to make. This is the balance between keeping them around to make sure we have attitude control if that's in question, as compared to letting them leave early and leaving us with some extra oxygen on board. So we'll talk about that with them over the next couple days. We'll assess the health of the computers, and it'll be obvious to you as you listen and follow along how that's coming along. And then we'll make a determination here in the semi-near future about whether or not we feel comfortable with relying on them for particularly attitude control, and then decide on the departure date for the shuttle. And that's all I had to report.
Thanks, Mike. We'll take questions. Let's start down here.
Ed Stoddard with Reuters News Agency. I have a couple questions for you, Mike, just regarding the computers. You say that 4 of the lanes are working. I was just wondering when they think that they're going to try to activate the other 2, because my understanding is that there are 6. And I was just wondering, so you say that they're going to try to make sure that they're stable overnight. I was wondering if you could elaborate on that a bit more. I mean, does that mean that they don't plan to try to do anything else, if I can put it that way, that they just want to see if they just function normally?
Let's see. It is our belief, based on talking to our Russian colleagues, that 2 of the computers had hard failed secondary power supplies, as I mentioned earlier. We believe the 2 that did not come up have this condition, so we would expect them not to come up. And in fact, I'm guessing that those will be the 2 they'll ask us to bring home for them. So I'm expecting to only have 4 lanes when the shuttle departs. And what was your second question? I forgot. Sorry.
Oh, I'm sorry. I was just wondering, you know, if they're so if they're just going to leave them stable overnight, does that mean that they don't plan to do anything else with them? They're
just going to let them run. We're not going to tax them. We're not going to ask them to do. They're not going to activate the Electron, the Batuk, all those systems that they typically utilize the command and control computer to operate, and we don't plan to do attitude control with the guidance, navigation, and controls computers. They're just sitting in a sort of a wait state, and they'll let them just run like that, and then tomorrow, depending on what the data tells them, I assume they'll dump the computers and take a look at their memory, but assuming it all looks well, then I would expect tomorrow we will begin the process of starting to activate other systems. As I told you, the command and control computer, they did activate the cooling systems inside, so it is actually performing a function and performing well because the cooling system is operating as expected.
Bill Harwood with CBS. The shunt that they put in, do you have any details about what it was? I mean, you kept saying what they bypassed. Do you know what they bypassed? I mean, was it a blown fuse was one thing? Was it a switch or?
Yeah, I can show it to you on a drawing. It's kind of hard to describe, but there is a circuit, a low voltage circuit, whose function I'm not totally clear on. We'll figure that out tonight. But it's basically a low voltage switch inside the computer. It's similar to the kind of circuitry you'd have for overcurrent protection, and one leg is to power and the other leg is to ground, and this is the switch that we've been talking about that in testing on the ground before they flew. It would have this sensitivity where you get noise on the ground circuit and it would cause this switch to trip, and when this switch trips, it is set up such that it turns the power off to the computer, and then it goes through a cycle trying to restart the power again. So what they did was they bypassed the mechanism by which that switch can turn off that circuit. And it's hard to describe to you, but that's essentially what they did. So the circuit stays on all the time, regardless of what that switch does. Now they can command it off and on, but they basically caused the circuitry to ignore this little switch.
It's almost like going around a breaker, is it not? I mean,
it doesn't provide a breaker type function. It is either over current protection or a soft switch. But either way, I mean, we'll figure that out, or you could ask our Russian colleagues directly. But tomorrow we'll let you know what it is. But that's the kind of circuit. It's very familiar to us.
Two real quick ones. You mentioned that the other teams are going to keep going while y'all see what's cooking. Are y'all going to try to work out a Soyuz or Progress attitude control anyway, since this has happened, or if the computers come up, do you cut that effort off? And the final question was, I'm just wondering what everybody's mood was. I mean, this has been a roller coaster week, I would think, for most of the guys in mission control on the station and the shuttle side, because you've got lots of stuff going on independently of what's happening with the computers. I mean, this was a really interesting week, and I'm just wondering what the mood of the team is after realizing it's not over yet, but what the mood of the team is tonight versus this morning when things seem pretty gloomy.
Well, I don't know about these guys, but they're probably exhausted. But to me, it is special because of the problems that we dealt with and not understanding exactly what the cause of the problem is. We're always a lot more comfortable when we know what the cause of a problem is. Once we've sorted that out, generally figuring out an answer is something we're able to do. So from my personal perspective, I was glad to, when the crew said they were up and running, even before anything else was said or any time passed, when two of them came up and stayed up together, I knew we had changed something for the better. And at that point, there's a little bit of relief because you know some of the other things you're working on, hopefully you won't have to try to go implement. And so from that respect, I think there's a lot of folks that are working on the teams, even though they're still working on the teams, I think feel a certain amount of relief that they won't have to implement some of the things we're looking at. As far as the team with the attitude control team, alternate attitude control team is what we call it, we particularly would like them to keep working on it. There's a couple of things they're looking at about how we hand over back to the gyros. One of the techniques we haven't been able to do yet is hand over directly from the shuttle to the control moment gyros. And frankly, that's a trick I'd like to know how to do. I can see several applications for that. So we'll ask these guys to keep working on that. They have come up with a technique they think would work to actually depart with the shuttle, and maybe the CMGs would hold attitude. And so we'll keep looking at both of those. As far as the shuttle and the Soyuz maintaining attitude, we'll look at that a little bit. We'll probably set that aside. That's going to turn out to be probably a little more challenging than we want to invest a lot of time on right now. So, but for now, all of the teams were instructed. We met at 5 o'clock this evening. All the teams were instructed to continue to operate as if the computers are not recovered, and so all of the teams continued on. So that's our philosophy for now. In about 24 hours, we'll take a look and see where we're at. But the alternate attitude control team, will keep them going. They're working on some important things for us for the future.
Gina?
Gina Sinceri, ABC News for Keith. You know, some of my folks in New York had a question because they watched the spacewalk today and they looked at, you know, the mirror that was carried out there, and they wonder, do you have like a big duplicate toolbox in mission control when you encounter a repair like this and you flip it open, you go, now let's see what's in here. Tell me a little bit about that process and how you pulled all this together for that spacewalk.
Well, I always think that's a great story to tell people because it's hard to describe what our job is in mission control, and so one thing that I always like to reference is the movie Apollo 13. And, you know, everybody kind of gets an idea of what we do when they came in and they dumped out stuff on the table and they said, all right, here's what we have to do and here's what we have to do it. And this is just a prime example of that kind of a repair where we knew we had to pull the pieces together. We knew we had to somehow keep them in place. So people threw out all kinds of ideas about adhesives, about the stapler, the pins, all kinds of different things. And so they collect in a room and they start throwing out ideas, and then someone will go out and build a mock-up that's fairly close to the real thing and say, well, it kind of works like this, and we bring in the experts that are the material experts, and we have an idea of what the crew is going to be, where they can work, how they can work, and we bring it all together in a room like they did in the movie and start brainstorming. And it's incredible to watch because everybody is very enthusiastic, and everybody knows that there's a goal to get these guys home and to build a technique to bring them back. And they come up with a plan and they build up procedures, and it's just amazing to watch.
And I have one for Kelly. How satisfying was it for you to watch Danny out there? It seemed almost seamless what he was doing.
Oh, it was very satisfying. I mean, like Keith said, the teams did just an excellent job putting the procedures together, and then to watch how meticulous Danny actually executed the task and how careful he was and made sure that he had met the exact requirements that we had specified for him. So he just did a really good job, and at the same time, you know, Jim Riley was performing his task just as we expected.
Mark?
Mark Carreau from the Houston Chronicle. I had a couple questions. The first one was for Mike Suffredini. The switches or circuits that were bypassed, as it were all of those in the computer, the German computers? And I asked that so I sort of know if you fly spare computers, are you sort of addressing whether or not this would happen again or whether you wanted to open up the other lanes?
Yeah, the circuit that was bypassed was in each of the computers, so they had a bypass in each one. And I would expect that to be a circuit that is bypassed on any replacements that come to orbit, but that's a future decision.
So though you may look at it right now, you're really not trying to chase a problem that might be in the circuitry of the S3, S4, or the or P3, P4, or somewhere inside the wiring of the space station. That sort of does not look like it's an issue at this point.
What we're trying to do, and we continue to do, is to see if the environment that is caused by the power system and this very large spacecraft in space is different than the design. As we get larger, we have this plasma field that we fly through, which causes this potential between the plasma field around us and the spacecraft itself. Every once in a while, it'll try to equalize, and this will cause. It's been referred to as a spark. In a lot of cases, you never see it. And we do that, that's just part of flying through space. It's kind of like atomic oxygen. You can't see it, but it's happening. As this spacecraft gets bigger, that potential gets bigger. And that may be one of the reasons why the sensitivity finally got tripped to the point these computers are acting up. And that is the design of the spacecraft. In fact, as the spacecraft gets bigger, it will grow. The potential between the environment and the spacecraft will grow. We are looking, though, at other things like how we're grounded to make sure we have our grounding straps connected right. Every time we build the space station, we add a new element. Each time we add new elements, you have to make sure how you've grounded that element with the other elements is correct. And we're looking at that to make sure everything is grounded the way we expected it to be. So we'll continue to look at things on our side. You know, we told you earlier today that the power quality coming from S34 is fine. So that was one of the first things we looked at. If in the end we've looked at everything and it's as designed, then we'll say, okay, well, that's the environment we're supposed to be able to live in. And I think our Russian colleagues took a major step towards desensitizing these computers to the environment that I expect we will be in for some time. Does that help at all?
I guess where I was just trying to kind of go with this is as far as providing new parts or spare parts if the computer, if you flew replacements, that sort of addresses part of the problem. But I think what you're really saying is you're going to chase this down, continue to chase down what's going on here to see if it is something beyond the computers or the circuits, and see if that.
Yes, we're going to. That's right. We're going to continue to look at the entire ISS and make sure that we're not causing something that's unexpected for the design, and we still have some things to look at in that respect. Once we're done, if we don't find any, then we'll go. I think, you know, this is the first time we've tripped over this kind of problem, and I'm sure our Russian colleagues are doing this because we've talked about it with them. They're going to look across all their systems to make sure they don't have this sensitivity in any of their other systems. But we have not seen anything like it in the past. So, but we're still on our side trying to make sure that we don't have something not quite right that's causing the environment to be worse than it should be.
Let's go over here. Questions?
Hi, I'm Mark Kirkman with Interspace News. Basically, two questions for Mike. I understand there was a simulation. No, it was supposed to be this afternoon for undock and handover. Did you learn anything from that about your ability to have shuttle undock and handover control? And also, since I'm talking about sims, let's say 2 months ago you had an integrated simulation and somebody handed you this scenario. I mean, basically you got a single point failure in a system that's supposed to be redundant. Would you have considered this to be a credible scenario at that time versus where you are now?
First of all, I don't know the results of the simulation. They're really just getting going, and so I haven't gotten any results from that, so I can't answer that. If you'd have given me that scenario before 6A, I would have told you it wasn't credible, but since 6A, when we lost 3 computers on the U.S. side and had to work through that, pretty much anything's fair game in simulation, and they pretty much offer up everything in simulation.
Bill?
Two for Mike. I was unclear about the timing of the 2 power supplies that are hard down. Did those guys fail earlier this week?
They reported that last night.
Pardon?
They reported that to us last night, early this morning.
Okay, so we don't know when
I talked to you guys at about noon today.
Right.
That's the time that we kind of knew that they thought they had 2 that were hard down.
Okay, but we don't know when they think they went hard down. I'm just wondering if they're associated with any of the work that's happened on this mission.
Yeah, I mean, all 3 lanes are working on all 3 systems before the shuttle arrived. And we actually had some dropouts right after docking, but they looked like normal dropouts. So they believed that as a result of whatever was causing these boxes to react, they believe out of the 6 power supplies, 2 of them hard failed as a result of the
whatever it was.
Whatever it was, right.
I got you. And then my last question was, the thing that was bypassed, whatever this thing is, I mean, it was obviously there, you're saying circuit protection of some kind. I mean, what was it that is there to protect against that you now don't have?
And that's an excellent question, and that's what we're going to talk with our Russian colleagues about at 1 o'clock this morning. They like us, need some sleep. So right after they got the computers activated and felt like they were stable, their primary experts went to bed, and we scheduled time to meet with them then at 1 o'clock this morning. So we should hopefully know more tomorrow.
Thank you. Tarek Malik with Space.com and Space News. Mike, if all goes well tonight and the computers perform as expected, I guess kind of what do you expect to happen in that scenario? Is it one system at a time that you would bring up? Is there a specific scenario or I guess a schedule for that? And I have a follow-up for Kelly.
Yeah, I haven't talked to my Russian colleagues about that. I would expect, I personally, if I was doing it, we'd bring up one system at a time, just to be able to watch each system come up and watch the load on the computers and see if you see anything different. But I have not talked to my Russian colleagues about how they intend to do that.
And for Kelly, I guess with this news, I mean, Fyodor and Olga have been staying up rather late. Can you kind of give me an idea of what, I guess, the crew is, aside from preparing for that fourth EVA, what they're going to do? Do they stand down and rest tonight? Is tomorrow kind of an off day for both crews, or what do they do?
It's not off day for both crews, but we have been trying to offload the activities on Fyodor's and Oleg's timeline just because they are essentially sleep shifting to try to do the troubleshooting while the rest of the crew is sleeping. Before the shuttle crew and the other members of the station crew went to bed last night, they did participate in some of the troubleshooting that we did on the U.S. side. So we are trying to just lighten their load so that they can get some rest during the day and then help troubleshoot at night.
Bill, did you have one follow-up? Okay, one more for Bill, one more for Mark, then we'll wrap.
Just real quick on your contingency stuff. Would you think that you'd still launch any kind of spare parts and stuff on the Progress whenever it finally goes, just to have some more backup capability up there? Is that something you think would?
Oh, I would very much expect that. I would expect the 2 computers that aren't working to be replaced, and I would guess that if they have the additional spares, we'll see as many computers they can get their hands on, up to 6 would be my guess. But again, I have not talked to my Russian colleagues. That's based on my experience with them. They're very thorough in these sorts of things, and if they can get them, they'll bring up a whole complement if they can get them and get them. You have to get them modified too. So we'll have that discussion. July 23rd might not be the date any longer. If they need extra time and can get the additional boxes ready, they may ask to move it back to the right a little bit. But we'll work with them, be very flexible, and fit that into the timeline whenever they want to fly.
Mark Carell from the Houston Chronicle. What are the major activities that are now planned for the 4th spacewalk, and when do you plan to rotate the S3, S4 at this point?
The activities that we're looking at for EVA-4, and Keith can jump in here, but during the first spacewalk, we had Jim Riley working on the first drive lock assembly. And then on the second spacewalk, we had them work on the second drive lock assembly. And what we found was they were actually cross-wired, so that when we commanded to one of them, it was actually driving the other one. And so we need to go back and look at that first one and get it into the proper configuration to make sure that it's ready to support. So we'll be doing that activity. We still have some of the launch restraints that we need to remove. We also have some activities that are involved to clear the translation path to the new work site that came up on the truss we brought up, and that will allow the next shuttle mission to install the S5 truss. Then we have some other items that we're looking at in terms of which tasks fit best in terms of get-aheads to support the stage EVA that's coming up, as well as the EVAs on the next shuttle mission.
Okay, thanks, Kelly. With that, we'll call it a close.
Welcome back. Here are our main stories. Hamas militants complete their takeover of Gaza. Arab leaders meeting in Egypt call for an immediate halt to the violence. And astronauts and cosmonauts carry out repairs on the Space Shuttle and the International Space Station. More on that now. NASA says newly repaired computers aboard the International Space Station could be put back in service today. Engineers are also monitoring adjustments to the thermal blanket on the Space Shuttle Atlantis. Miles O'Brien has details of the repair jobs.
The troubleshooting and the trouble stitching all paid off. After a busy, tense 24 hours, the shuttle and the space station appear to be in much better shape. Cosmonauts Fyodor Yurchikhin and Oleg Kotov, working to coax the critical command and control computers on the space station back to life, used jumper cables to bypass a suspect switch on a power supply. They turned on 2 of the 3 pairs of computers, and they came back to life. Only 1 pair is needed to run the station, everything from oxygen generation to the toilet to the direction the outpost faces as it orbits. The trouble began as the week began, shortly after the Atlantis crew installed some new solar panels on the station. Engineers in Moscow and Houston suspected there was something wrong with the quality of the electricity generated by those arrays. But now it is unclear if the arrays had anything to do with the failure at all. The fix came in while a pair of shuttle spacewalkers were out. With his feet attached to the end of the shuttle robot arm, astronaut Danny Olivas made his way to the orbiter's tail and got to work on the peeled-back thermal blanket needed to protect the shuttle on re-entry.
I was going to ask you guys to keep an eye on me.
Olivas tucked the blanket in and then, using a stapler designed to close a wound on a hurt astronaut, healed the heat shield. NASA engineers were worried the blast furnace of re-entry would char the graphite skin beneath the blankets. There will be one more heat shield inspection before the shuttle gets a green light to come home, and there will be some worry about those computers until engineers fully understand what happened. But what started as a dark day for NASA took a dramatic turn for the better, thanks to some Russian ingenuity. Miles O'Brien, CNN, New York.
American astronauts in a 6-hour spacewalk repaired damage to the shuttle's heat shield. Russian cosmonauts on the space station have been able to restart the computer systems that control the station's positioning and its oxygen supply.
2 American astronauts in a 6-hour spacewalk used a medical stapler to seal a gap about the size of a hand between sections of thermal insulation. They came loose when Atlantis docked on the space station last week. 4 years ago, problems with the heat shield of the Columbia space shuttle caused it to explode on re-entry, killing all 7 crew on board.
The concern was not nearly what it would have been in the Columbia case. It's a different location on the space shuttle altogether, but we do want to make sure that the area was adequately protected, so it's now stapled back and pinned in place where they've run some pins into the local tiles nearby as well.
Meanwhile, on the space station itself, where the computers that control its positioning and oxygen supply have been crashing repeatedly over the past few days, Russian cosmonauts have reported success in getting some of them to work again.
They want to let the computers run for a while overnight to make sure they remain stable, and then tomorrow, if everything looks well and the data indicates the computers are doing all right, then I would expect that we would slowly begin to activate the systems on board.
But the computers will continue to be closely monitored while Russian officials consider whether to speed up the dispatch of replacement components. A close eye will also be kept on the shuttle's heat shield. Atlantis is due to return to Earth on Thursday. Chris Farfoy, BBC News.
An der US-Raumfähre Atlantis, die an der internationalen Raumstation ISS angedockt ist, haben Astronauten den Hitzeschild repariert. Wenn alles nach Plan läuft, wird die Atlantis-Crew am Dienstag die Heimreise antreten. Auch an der ISS führten Astronauten Reparaturarbeiten durch. Sie brachten 4 der insgesamt 6 ausgefallenen Computersysteme wieder in Betrieb.
Good morning, Atlantis. That song was for Danny.
Hey, Shane, good morning. It's good to hear your voice. I want to thank the folks at the University of Texas at El Paso, and go Miners.
And Sonny, we need to congratulate you this morning as well. You're setting records every second you're up there.
It's just I'm in the right place at the right time, and it's just an honor to be up here. I tell you what, even when the station has little problems, it's just a beautiful, wonderful place to live. So you guys, thanks for all your support.
Okay, big picture regarding what we're trying to do with O2 here is maximize our dock time capability, essentially, in support of the further investigation of the SM computer anomaly. And where we are with that is we have enough O2 to guarantee at least one extra docked day. However, there is a little more O2 available, not enough to give us a second day. However, there is enough that we'd like to put the O2 transfer in work today. And I think we're going to move over about 55 pounds of O2. To do that, we have a cryo-config onboard shuttle that needs to be completed first. And then when that's done, we can put the flight plan O2 transfer steps in work as written in today's execute package. How copy?
Okay, Hawk, we copy. We were setting up to do this in about 15 minutes. And Pat will take the cryo config on air-to-ground 2 when you're ready to pass it, and then at 1600 we'll be ready to do the O2 transfer.
Okay, that's most excellent. We'll get to Pat in a moment. The other big picture note I have for you is we can inform you that your TPS on orbiter has been cleared for entry.
Okay, that's great news, Houston. Thanks a lot.
You bet.
Gina Sinceri, ABC News. Let's start with Sunny. You broke a record today. What did you do to celebrate?
Had a lot to do up here today. We're still working on the Russian computers as well as working on getting the hydrogen vent valve installed on the inside. So I think I had a couple wrenches in my hand, and that was pretty much how I celebrated today. But everybody here said congratulations, and I just want to reiterate, I was just in the right place at the right time. There's many people who could have done it before me, and many who will probably surpass that record in the future. But thank you.
And I have a question for Clay Anderson. Clay, you sort of gotten a crash course in space station maintenance this week. How's it been going?
I think I'm hanging in there. It's kind of reminds me of one of my first swimming lessons when I just got tossed in the water and they told me to kind of survive. So everybody's been very helpful, Sunny especially, and we're going to get through all this just like NASA always does.
And then for Oleg and for Fyodor, gentlemen, how is the troubleshooting going on those Russian computers?
So, in first time it was too terrible for us because we don't understand about everything. Every computer is computer, yes, and nobody understands very well about what is thinking and what happened in next time. But now we fix this problem and everybody in Shuttle guys, and we are very happy about this situation. I hope in MCC Houston, MCC Moscow, everybody is very glad for this situation. And we fixed this, and we continued our flight. It's good news.
Thank you. This is Tarek Malik from Space.com and Space News, and my first question is for Commanders Yurchikin and Strelko. This last week has been kind of a roller coaster for some of us on the ground here, watching you wrangle solar arrays and the computer glitches and whatnot. How tough has it been, to have, a docked mission as well as kind of wrangling all of these challenges?
Of course, the shuttle flight is a very interesting flight. Yeah, it's like expedition flight, but for very short time. For example, in our expedition, we are flying with Oleg about 2 months, and we had only 2 EVAs. Shuttle coming soon, and now had 3 EVAs. Tomorrow we'll have 4 EVAs. It's expressive, very expressive time. Of course, we are very busy, but every day we check, every evening we ask each other, okay, it's done for this day, all tests done, and we are happy for every day. We are happy for our shuttle mission because for me, for example, this is new. I again met Atlantis, my first space vehicle. It was Atlantis. For everybody, it's very good news. For Sunny, for example, she returned home. For Clay, he began his first flight. For me and Oleg, it's the first docking with shuttle in our mission. For Shuttle, it's his mission, and for I think, Shuttle guys, it's first flight. It's a good day, very busy, very sometimes terrible, sometimes difficult, but very nice time for everybody of us.
Thank you. And for Jim, you know, you have 4 spacewalks for the mission. We've seen the station get a new starboard side, new solar arrays. How does it feel to kind of be stepping out of the Quest airlock? You know, you helped install it, and here's this machine that is growing in nature.
Well, the first impression was looking out that door and seeing the Earth go by 200 miles below on the tail of the orbiter, and that was pretty impressive. And then the really big impressive moment was being out at the end of the truss as we were finishing up some of our work, getting it ready to unfurl the solar arrays, and looking off to one side and seeing the horizon disappear in 3 directions, and then turning around and seeing this massive piece of equipment behind us that we've been building over the last 2 years, and looking at it and going, this is what we've done. And it was a pretty impressive moment, just to be able to sit back and look at that, and look at the engineering feats that we've accomplished between Russia and the rest of the international partners and ourselves.
Hi, everyone. It's Bill Harwood with CBS News. Let me ask Oleg Kotov a question, please. Fyodor has answered this already, but let me ask you. The effort to get the computers going, struck everyone on the ground, is really something on the part of the Russian engineering team on the ground, and of course you guys had to carry out their strategy. What was your sense of all of this, and how did it go? Were you worried in the middle of this? Were you confident all the time that you would get this resolved? And what might you say to the engineers on the ground who figured all this out?
Yeah, that's a really good question, because at the very beginning we were a little bit worried about the state of the computer, because you know this happened first time when a whole set of Russian computers crashed at once. So, but we're sure that our ground team, as our FCC Moscow with Houston support, can troubleshoot this problem, and it's become true. You know, as yesterday and actually this morning, we've finished our troubleshooting activity, and we performed this task, and now we have a good set of whole computers on our station, and station again looks pretty good and in good shape, and we're ready to continue our mission and path our station to the next mission sometime. Thank you.
Thank you. And Sonny, let me ask you a question about that as someone who's leaving but has great familiarity, obviously. Is there a message in all of this to folks who don't pay a lot of attention on a daily basis to the station, the complexity of it, or the challenge of building and maintaining a machine like that in orbit? Any thoughts you have to share, would appreciate. Thank you.
Any thoughts you have to share, would appreciate.
Okay, Bill. Well, I think my overall thought is, you know, we take spaceflight for granted, and it still is pretty darn dangerous. And we know we're living in an environment that's it's not really friendly for humans to be. As you've noticed by watching the spacewalks, the spacesuits aren't a joke. They're pretty heavy-duty equipment, and the equipment that we use out there to move around and to do the jobs that we're doing out there is pretty serious. And likewise, the vehicle that we're living in here, you know, it's not just a tourist vacation place. It's a place that's living, working like a ship, and we're the ones who keep it going. We're the ones who make sure the toilet works, make sure we have air to breathe and stuff like that. So, you know, it's a serious place, and we're doing serious business and serious science up here. So I think that's the one message. It's space isn't you know, just for tourists. It's actually, we're actually getting a lot of work done up here.
Robert Perlman with CollectSpace.com. A question for Sunny first. As you prepare to come home, what have you physically packed to bring home with you? What are you leaving on the station of yourself? And in a larger sense, what's the spiritual message you take away from living on a space station for 6 months?
Real quickly about stuff that I'm taking home and leaving. Well, you know, 117 was pretty packed up. The truss was really heavy, so they don't have a lot of storage space on the mid-deck for just personal items. So I'm leaving actually quite a bit of stuff here. We're allowed some stuff to come back on 13A.1, the next shuttle flight. So some of my personal stuff most of my personal stuff is coming home on the next flight, but I'm bringing home a couple shirts just for a good memory of the flight that brought me up in Expedition 14, Expedition 15, and now 117. And of course, a picture of my dog. I might have to stay here on the space station. I might have to hide it for some future crew to find. A reflection on my time up here in space for 6 months, you know, it's I think the biggest thing that I noticed was how amazing the human body is, how it is able to adapt and be able to function in such a different environment, in actually a fairly vicious environment like I just described in the last question. I don't even feel like floating around is anything different than on Earth when you're walking around. It feels very natural. It feels like what you should be doing, and it's amazing how quick your body can adapt. We're doing a lot of things up here science-wise to help us go on to understanding how we're going to build a space station potentially on the moon, and then how we're going to build and live for extended periods of time someplace else, and then we can learn how to potentially go on to Mars. So this is a necessary thing, a necessary step in our future plan for the space program.
And for CJ, working off something Sunny just said, somewhere stowed inside the locker on Atlantis is a 400-year-old remnant of the first permanent English settlement in North America. As someone who's been to the ISS a few times, both at its beginning and now as it nears completion, in your opinion, does the space station represent the same type of pivotal shift in human migration?
I believe it does. It's not going to be a quick migration, though. You know, you mentioned the time frame of the 400 years. Hopefully, within our lifetimes, we'll see what Sunny was just describing of a colony on the moon where people actually live there. They don't just visit there. They live and work there. And I think we'll hopefully see exploration beyond that, too. So there's all good goals.
Todd Halverson of Florida Today. I guess for CJ, I'm wondering if you have any real concern about re-entering with the OMS pod blanket in the condition that it's in. A lot has been made of it down here, and I'm just wondering what your thoughts are now that the repairs have been affected.
Todd, I think you heard a lot about the team that developed the repairs, and I was inside with Pat Forrester yesterday when Danny Olivas did the repairs. So we had a very good view on the WVS system of the work site, and I have a lot of confidence in Danny's work, so I think that we're going to be in a good shape.
For Sonny Williams, I'm wondering what you might remember as maybe the biggest highlight of your expedition, and what you're looking forward to most about coming back to Earth.
I think one of the highlights, of course, were the spacewalks that I participated in. You know, when you're outside and the only thing between you and space is your visor, that's pretty special. But I think the biggest moment for me was actually when Expedition 14 left, and I was feeling like I was the only American up here and hopefully representing our country pretty well and all the good that is represented with the United States.
Thanks. And for Clay Anderson, 15 times I think you applied for the astronaut corps, and you finally got in, and now you're finally on orbit. What are your first impressions of space flight, and is it everything you've anticipated?
Incredible place to be. It's an incredible place to live, and I'm sure that those thoughts will be even more cemented in my brain as I go through my tour up here with Fyodor and Oleg. You know, perseverance pays off, and I'm very proud to be here, and I'm proud to represent the United States and the programs that NASA and the Russian space program have put forth, and all of our international partners. So I'm just like Sonny. I want to do a great job, and I want this to be a very memorable occasion.
It's Mark Carreau from the Houston Chronicle for Sonny Williams. Are you prepared to return to gravity, and how do you think you'll do when you start to readjust? Thanks.
Well, I'm a little bit nervous about that. To be honest with you, I've never done this before, so I don't really know how everything's going to work out. But I think you guys know that I've been working out pretty hard up here. I was a little bit sad we couldn't use the TVIS for a day or so because of the computer program problem, and so we had to sort of shut down activities in the SM. And I was a little bit worried about that because that's one of the best things I hear for you to prepare you for getting back working on Earth again. But I think I'll do okay. I've worked as hard as I think as anybody can work up here physically, so we'll just see how it goes.
Juan Lozano, the Associated Press. I guess for anybody who wants to answer, if anybody could talk about it, as far as what kind of the computer problems this past week, what kind of impact did it have on sort of the quality of life on the space station? And also, was there ever any point anybody was really worried that the problems couldn't be resolved?
Well, I can speak just from the crew on Atlantis. The first thing we noticed was the amount of effort and work that the expedition crew was doing over here. I think that long into the night while some of us were sleeping, they were in here working on the computers, and for that we are very appreciative. We had to make a few adjustments as far as the amount of power that we used, but nothing that we couldn't complete the mission with. And some of the things that we turned off that would help clear the air, some of those things we noticed. But for the most part, it was easy for us, but the work, the real burden was on the expedition crew.
Jeff Franks with Reuters. I'm just curious, after the problems on the station this week, do you think that people should be more confident or less confident in the safety of the space station? Also, second question, in terms of the logistics question, just transfer, are you guys ahead, behind on the transfer of cargo due to the work you've had to do on the computers, or no?
For the first question, I would say definitely be more confident. It just shows you, given any problem that we face in this environment or situation, that we can overcome it. And we've done that many times, and we just did it again. It's a wonderful testament to the folks at NASA. As for transfer, JR is just pretty much done with that. We are very close to finishing that up, and we're looking forward to getting that complete.
David Waters from Central Florida News 13 for Danny Olivas. Tell us what you were thinking when you were out on the end of the robot arm. You were doing these repairs with a medical kit. How did that feel to you?
Well, you know, I had a great deal of confidence going into it because I knew that the procedures which had been developed, knew a lot of the people on the ground who developed it because I had an opportunity to work with them as we worked through some of the repair efforts after Columbia. And the solution they came up with was certainly in line with what my thoughts were on how to proceed, and so, you know, everything had been done in such a fashion to really make it as foolproof as possible. And so, you know, I think the proof is in the pudding that a fool like myself could, you know, get that done and make it meet the requirements. So I was feeling very, very good about it.
And for Sonny Williams, you've all been dealing with ISS computer issues. How hard has that made it playing catch-up?
Well, these two wonderful gentlemen right around me have, like mentioned before, have really worked day and night to make sure the computer problem hasn't really impacted any of the mission that's going on or really any of our daily life up here. They've done a tremendous effort. Like I mentioned, there's a couple things that we couldn't use, like the treadmill and stuff, just because of the power loads and the heating in that part of the space station, but that was it, and that was maybe for 24 hours. It really hasn't impacted us at all.
Peter King with CBS News Radio, and for Sonny, while you still have the mic, I know you've talked about being in the right place at the right time on setting the record, but a couple things. First, were you aware that this is also the anniversary of Valentina Tereshkova's flight? And second of all, would you like to go back, and how long a respite or a decompression time would you like before you would go back to the station?
To be very honest with you, I didn't realize it was the anniversary, but wow, that's pretty neat. I'm pretty honored to share a similar date in history as Valentina Tereshkova. That's pretty amazing. I would love to come back. Like I have mentioned before in the past, it's a beautiful place to live and work. I mean, what a great view of our home planet, and lots of good science that we're doing up here. So, you know, I would absolutely love to come back. But, you know, there's a long list of astronauts ahead of me that need to get up here and fly it and experience it for themselves, so we can go back and tell our families and our friends all over the world and country how beautiful it is. So we'll see. We'll see how long. I don't know, maybe 4 or 5 years. Maybe I'll come back. We'll see.
For Steve Swanson, with repair and retraction done by the other EVA team, the average observer may think tomorrow's tasks are a little bit mundane and ordinary compared to the more spectacular stuff. Wondering if you feel bad about not getting a crack at doing those repairs, and tell us a little bit about why tomorrow's EVA is going to be so important.
No, I don't feel bad. Every EVA is good, a good EVA. And they did a great job the other day, and I'm really proud of them. For tomorrow, our biggest task, I think, is to get the alpha joint open and ready to go so that the solar rays can track the sun. And then we can also then have the MT, we'll clear the path for that, and have that be able to go out as far as it needs to go for the next mission so they can put on the next piece. Those are the two big things I believe we need to accomplish tomorrow, and those are big keystones in the building of the space station.
And my last question, this is for Commander Sturko. You know, Sonny kind of answered this a little bit, but I'd like to have your perspective on it. You know, you started this mission expecting perhaps one set of problems with the retract and that sort of thing, and instead you wound up with a whole lot of other problems that you all met head on. I'm just wondering your feelings on the lessons learned about handling life in space day to day and the things that come up.
I think it's all a good example of what the NASA and the RSA can do working together, and once we get the international partners living up here, I think we can accomplish great things in space. Let me just let our pilot, Lee Archambault, comment also on how well the mission's been handled and some of the impacts from his perspective.
You know, to this point, we've had 3 of our, what was going to turn out to be 4 EVAs, and things have gone very, very well. We had a real complex EVA yesterday that also included operations of 2 different robotic arms during the same EVA. So we're very, very happy with how the technical aspects have been going. But from a first-time flyer rookie perspective, the technical aspects aren't really the biggest challenge for me. The biggest challenge is just learning how to adapt to zero gravity and learn to live in space and get by in space. Just even the mundane things like transiting back and forth from the station to the shuttle, learning how to eat your food, just getting around without gravity is oftentimes even a bigger challenge than a lot of the technical things we do, because we get a lot of training on the technical aspects of the mission. But it's for the first-time flyers particularly, adapting to zero gravity provides a unique challenge that can't be practiced anywhere.
Eric Solomon, Channel 48 News in Huntsville, Alabama. Just a quick couple of questions for you guys. Most of my questions will be related to to Marshall, and my first one goes for the shuttle crew. If you guys could just talk a little bit about the launch. How was the launch and the ride-up?
Well, I can tell you, I was sitting on the mid deck with Jim Riley and Clay Anderson, and I will tell you, it's a spectacular ride. You know, even though we didn't have much of a view, the mid-deck lockers don't make for a very great, you know, panoramic, scenic view to remember. But certainly the ride was a lot of shaking, a lot of vibration, and you could certainly feel every phase of the flight. It was a smooth ride. We got here without a problem, and so we certainly did enjoy it.
Just to follow on, I was on the flight deck and got to see out the windows, but I agree with Danny. It was quite amazing. It was an amazing ride. It did shake, and the view, though, was tremendous. You could see, as we turned over, you could see the horizon coming out the windows, and it was quite a view.
All right, and my next question is for Sonny. First off, love the hair. I wanted to ask you about the Payload Operations Center and how is it working with them, and how's that been going for you guys?
They're awesome. They're great. You know, we have our daily planning conference, so we're talking to them every day, and then we're working here in the lab doing science experiments and interacting with them on a daily basis, sometimes hourly basis, depending on the science experiment we're doing. And the folks there are just great. They're awesome. They're professional. They're always there to answer questions. They're in touch with all of the investigators all over the world and are able to answer any questions we have. And I really appreciate working with them, and I'm going to sincerely miss doing the science and being able to talk with them, particularly on Saturday morning.
All right, and just for anyone with the space station, if you could talk about the oxygen generation system that went up last July during the last spacewalk. You all installed a special vent. Tell us about how the procedures went with that and what impact that will have.
As the International Space Station ramps up, truly become international by bringing in some of our partners, we need to have other capabilities, dual capabilities to some of those that are provided by the Russians in the Russian segment. One of those is to generate oxygen on board, and Jim Riley did an excellent job installing and kind of readapting vents that we already had on the station now to allow us to vent hydrogen to space. So he did his part yesterday successfully, and today we were up inside the cubby holes with wrenches and beating things up and trying to get the inside part attached so that we can finally test the OGS, we call it the oxygen generation system, and make sure that we can generate O2. And that's just a sign of some of the things to come as we ramp up to new modules in the future and new partners and new crew members. We need to have additional capabilities.
All right, and my last question will be for anyone to answer. It's obviously the Space Camp's 25th anniversary. They just graduated their 500th camper. Just could someone talk about how important the public interest is in the space program?
Well, more specifically about Space Camp, anytime you can get kids interested in the sciences, math, and technology, the things that are most in demand in our world is as fast as it's changing is definitely a good thing. And Space Camp has that ability to fire that spark in kids like almost no other program around. So the fact that they're around and they're doing it today is a great thing, because we need more engineers, and NASA needs them every day. So anytime they get into the university and come our way, we'd love to talk to them. So we're definitely in favor of those kinds of programs, and we think it's a great thing that they got their 500th of many thousands out this year.
Atlantis ISS, this is Houston ACR. That concludes the event.
Okay, this is the 117 video for Flight Day 9, and you can see Danny is making a burrito or a breakfast taco here. He's got sausage and scrambled eggs and a lot of hot sauce and a little bit of mustard on there. and it looked really delicious. Of course, you can see it's a challenge in space getting all that to stick together, and he did a really good job with it. Here's Swanee. Again, this is in the post-sleep period, just sending a message home to his family. You can see it's interesting because he's hanging on the ceiling when he does that. Of course, we like to jump on the bike first thing, get a little morning bike ride in. Chance to exercise on the resistive exercise device over in the station node. One of the first things we set up was an oxygen transfer to take shuttle oxygen and put it into the ISS airlock O2 tanks. That involves some commanding on the computers. And then Oleg and myself hooked up some hoses in the airlock and then through some valves that are in the shuttle docking system in the vestibule. Hooking up of the oxygen transfer is high pressure oxygen can be very flammable, so we're very careful. We wear surgical gloves when we actually make the connections. Right there, we're just inspecting the valves. Of course, it's a little dark in some areas, so it's always good to illuminate with a flashlight to make sure that crew member's not throwing an incorrect switch. Here comes Danny translating through the lab area. You can see the crew has adapted well to the zero-G environment. It's a little tricky translating through the station. Make sure you don't kick any of the expensive equipment that's hanging around on the wall.
This is Dale, and here's Swanee doing the same thing. We're a little bit heading for the airlock, and these guys are setting up all their equipment for the EVA that they're going to do tomorrow. And here comes Pat doing his Army flip. Right now, this is Clay, and I'm checking the pressures. We've set up a system now that JR installed the hydrogen vent valve on the outside of the station for our oxygen generation system. My job on the inside was to set up all the connections and complete the work that Sonny and Mike Lopez Alegria did before. Here's Pat on the right and Steve Swanson Swanee on the left, and these guys are doing their prep for the EVA for tomorrow. They're getting their helmets ready, putting some anti-fog inside there so that the visors stay clear. And here's CJ and I packing up some of the gear that's coming home, or Brew, I'm sorry, packing up some of the gear that's going to be coming home with us. That's some of the equipment that we took off the outside of station on EVA 1. And there's Brew, and he's working on one of the laptops in the station.
Here you see Fyodor and Oleg, and they are doing further on troubleshooting in the service module, working on the computers and using the scope meter to try to identify where there might be some of that electrical interference that I was talking about that me and Swanee were reconnecting the electric connection for us.
And that's me, Clay, zipping up inside the station to work on the valves that we talked about for the hydrogen vent that JR had put on the outside. We also are working with fittings that need to be cleaned, and we're dealing with some cleaning right now before we actually hook up the final connections. Once we do that and everything's connected, the ground control team will begin to open various valves and check for pressure integrity along the way to make sure that when we finally open all the connections that we need, we can vent hydrogen to space. And here's Pat and Swanee again, Pat on the left, Swanee on the right, and we're doing a procedure review, walking through all the steps for what they're going to do tomorrow on the EVA, and their primary task is to remove all the equipment now that will allow the SARGs to rotate, and so the solar arrays that we've just installed out there will be able to track the sun, and they will also open up the translation path for the mobile transporter for the big arm.
This is just finishing up some O2 transfer with JR up on the Orca pump, and we're commanding the RPC to open. That's going to disconnect electrical power. After we did that, then we deconfigured the hoses, the O2 transfer hoses that I mentioned earlier. And then the cooling hose, I think you're going to see here in a minute. We're going to go ahead and disconnect that from the Orca pump and put it back in the crew lock to provide cooling and ventilation for the crew in there tomorrow when they get set up for the EVA.
And here you can see Daniel Levis working with the crew, EVA crew tomorrow, Steve Swanson and Pat Forrester, getting them, putting them in bed in the airlock tonight, and that's where they're at right now. In their camp out overnight in the airlock. What you'll see next is Steve Swanson and Pat Forrester donning their masks for their pre-breathe, which lasts about 45 minutes.
There's Sunny packing up to go home. She says hi to Marcia. There's a note that Marcia personally wrote. Marcia Ivins, she did a lot of bench reviews for this crew. We'd like to thank her for all her support.
And here you can see Swanee and Pat with their masks on for a 45-minute pre-breathe, and after that they'll be camping out in a depressed airlock overnight.
Im russischen Teil der internationalen Raumstation ISS sind alle 6 Rechner wieder in Betrieb. Alles sehe ziemlich gut aus, das sagte Kosmonaut Oleg Kotov. Nach Angaben des russischen Herstellers waren die Rechner wegen einer elektrostatischen Entladung ausgefallen. Mit Überbrückungskabeln wurde der Schaden behoben. Inzwischen bereiten sich 2 Astronauten der angedockten US-Raumfähre Atlantis auf ihren 4. und letzten Außeneinsatz vor.
Die Krise im All ist bewältigt. Der Besatzung ist es gelungen, auch den 3. und letzten Teil des Computernetzes wieder hochzufahren. Mit Überbrückungskabeln hatten russische Kosmonauten die Navigations- und Zentralcomputer wieder zum Laufen gebracht. Ersten Untersuchungen zufolge waren die Rechner wegen einer elektrostatischen Entladung, ausgelöst durch ein neu eingebautes Sonnensegel, ausgefallen. Ein Computer ist eben ein Computer, scherzt der Kosmonaut Yudchichin. Und niemand weiß so genau, was der denkt und was künftig passieren wird. Aber jetzt haben wir das Problem im Griff und wir sind sehr glücklich. Die Rechner sind vor allem für die Stabilisierung der Raumstation in der Umlaufbahn notwendig. Auch Temperatur und die Sauerstoffversorgung an Bord werden über die Geräte geregelt. Unterdessen bereiten sich 2 Astronauten der angedockten US-Raumfähre Atlantis auf den 4. und letzten Außeneinsatz der Mission vor. Das Space Shuttle soll sich am Dienstag auf die Heimreise machen und dann am Donnerstag wieder auf der Erde landen. Mit an Bord wird auch die amerikanische Astronautin Sunita Williams sein. Seit Sonntag ist sie die Frau mit der längsten Aufenthaltsdauer im Weltall.
Good morning, Atlantis. Happy Father's Day. That song was for JR.
Hey, thanks very much there, Shane. That's the theme from Band of Brothers, and that says a lot about our crew, and I want to thank my kids for making that dedication for me today, and also in remembrance of all those fathers who aren't home that are serving overseas, and the mothers that are also serving overseas, helping to keep us free so we can do what we do. Thanks again. Good morning.
Thanks to you. Thanks, JR.
This is a view inside the station's Destiny laboratory module with astronauts Clay Anderson and Sonny Williams working at the robotic workstation. Together they will be maneuvering the station robotic arm into position atop its mobile platform so that that platform can be maneuvered later today. This is a view on the outside of the International Space Station showing the space station robotic arm.
Anyway, we need it obviously for a fly around, but it's not a big deal. Just wanted to make sure it got looked at before the next flight of Atlantis.
Sounds good.
The arm being maneuvered into a park position on top of its mobile base system, securing it in place so that that base system on the mobile transporter can be moved later today down the railway on the station's truss structure, moving to a new work site on top of the new S3, the starboard 3 truss element, and then back to its current location at the work site on top of the starboard 1 or S1 truss. This is a view inside the station's Destiny laboratory module with astronauts Sonny Williams and Clay Anderson, two station crew members going through a handover from Williams to Anderson, serving as the Flight Engineer 2 for Expedition 15 and the NASA Space Station Science Officer. The pressure in the crew lock section of the Quest airlock continuing to drop slowly in the final steps of the preparations for today's spacewalk.
Looks like it's daylight. Sweet.
The hatch on the Quest airlock is open. You can see it here in this view at the top of the screen.
O2, rate 3.5. SOP D is 6160. Battery volts DC 19.2. Battery amps 3.2.
As the crew members confirm the readings on their spacesuits before exiting the airlock, this is a view from one of the helmet cameras on one of the spacesuits. looking out the hatch at the Earth below.
Water pressure 14.6. Data combo. Battery volts 32.0. And my pressure gauge is at 4.3.
Gentlemen, I'd like to hand you off at this time to JR, and you guys have a great EVA.
Okay, nice job, Denny. Thanks, Denny.
Okay, and we've got the thermal covers open, and we're ready for you to egress the airlock. Pat?
Didn't that work?
Astronaut Pat Forrester, the first to exit the airlock hatch. This is a view from his helmet camera video.
Okay, and you'll be picking up your 85-foot safety tether, and that's the one that's immediately to your left.
Copy.
And Atlantis, Houston.
This view now from Forrester's helmet camera.
Blockage. I'll let you know when we're ready to hit play again.
Okay, I think that's about 90% of it, but we'll just leave it right there in the machine and just give me a holler, please.
Great, thanks.
Bravo 7 JR, counter 3.5 is set.
Okay, and that'll be about 9 turns, 20.
Copy.
Astronaut Steve Swanson is continuing to remove 3 launch restraints on the joint there, while astronaut Pat Forrester works at the drive lock assembly number 2 to help Mission Control Houston confirm its installation and operation to rotate the joint.
Houston, Atlantis, we can verify there is a neutral indication in the motor housing window. And on your go, we'll continue with bolt ops.
JR, we copy, and you have a go.
Okay, copy that. And Pat, first one up will be bolt 1 Charlie, which is going to be on the right side as you're looking at it.
I see it.
And when you're set and ready, I'll get some PGT settings for you.
Astronaut Pat Forrester has confirmed that the drive lock assembly did change into a neutral position after commanded by the Falcon expert flight controller here in the station flight control room.
Just need to come across to the other side there. Okay. Tell me like that, is that good? Yeah, just keep an eye on me. I just kind of want to keep my tether running. Yeah, I understand. I'm just going to JR, 4 Bravos in the bag.
In the bag, 4 Bravo, got it. Swanee, and you're heading for number 5, I think.
Yeah, that's 5, we got a red on it. Just good looking for current.
Okay, sounds great. And big picture, while Pat's getting in position here, Swanee, you're probably going to be a little bit ahead. So what I'm thinking, and you guys let me know what you think, is to move the APFR from S328 over to the dragline keel pin.
I'll get that done after this launch restraint. How about that?
Sounds like a plan.
Now 1 hour and 31 minutes into today's spacewalk, this view of astronaut Pat Forrester just securing all the bolts in place on the drive lock assembly number 2 on the Solar Alpha rotary joint. The flight control team here in the International Space Station Flight Control Room will command that assembly to engage into the joint, connecting the teeth of the drive lock assembly to the gear of the rotary joint.
And Pat will just be hanging out here for a couple of minutes till they get the drive command initiated, and then we'll be checking for pinion gear meshing with bull gear.
Sounds good. I'm in a position to watch the indicator, the drive indicator first, and then I'll move over and check out the teeth and gauge.
Okay.
And Swanee, when you get there, it'll be a clocking of 6, and I've got the rest of them for you when you're ready.
Clocking of 6, and just verify, please, with 5.
It is with 5.
Thanks.
Atlantis, Houston, for EVA, we've sent the command.
Copy, thanks, Megan.
And I see it, JR, and we have a D in the window.
Okay.
I verify good tooth engaged. And if you want some WBS, just give me some direction.
And I think the visual verification is good. There's nothing here. Break Houston, Atlantis. If you concur, we'll have Pat reinstall the DLA-2 cover.
JR, we concur. We're ready for that.
Okay, Pat, we are ready to put the cover back on.
In work.
Astronaut Pat Forrester has completed the installation of the drive lock assembly number 2 and helped Mission Control confirm its activation and engagement on the Solar Alpha rotary joint. This one of 2 of the drive lock assemblies that rotate the joint.
Hey, Pat, imagine you probably heard me talking to Swanee and the big picture. What I'm having him do is come over to 6 Bravo, which is right above your head. And what I'm thinking is to have him break torque and you follow up with PGT and remove. How does that sound to you?
Sounds good. Got one more tether to get.
And we'll do a quick glove inspection, and then you can just hang there for a second while Pat or while Swanee breaks the torque.
Sounds good. Looking for the best spot. Well, when you find it, tell me about it, will you? I'm coming up there next. Right. That's it.
This is now a view from a camera on the outside of the International Space Station, looking at the forward side of the S3 truss element. Astronaut Steve Swanson in view as he and astronaut Pat Forrester are removing the keel pin that's extending just up above and to the right of Swanson's head in this view. They'll rotate that into the truss and out of the way so that the mobile transporter can move up and down the railway of the truss there. This is a view from the camera on astronaut Steve Swanson's spacesuit.
Sorry there, Pat. That's all right. Yeah, I did torque 21 tons, 15 on the torque. I think 22 is the correct number, Pat.
Yeah, 22 is the correct number. And we are ready to rotate. When you get ready, give me a call.
Okay, I think we're going to get him now just a little outboard. That's correct, and just way. And you can just slide that crew lock bag. I've set it up so it'll just slide. Okay, thanks. Up, Adam, clear. All right. I think what we're going to try and do with this thing, a little bit nice and slow. Kind of bring it up at an angle like this. Good. Sure your tether's clear. Yep, I'm holding. holding it back. My tether is clear. You're by my tether. There you go. Sorry, there you go. Yeah, I was just moving it nice and smart. We're almost there. Nice and slow. Okay. I can verify that I've got mine in the clip. And it's lined up for mine. Perfect. You can hold it, I can put it in. You bet. Hang on. I've got it. Okay, you have it. I do have it.
This is Mission Control Houston, now 3 hours and 42 minutes into today's spacewalk. Astronaut Steve Swanson translating and moving back to the Quest airlock to stow a bag of equipment and supplies from the first part of the spacewalk. Astronaut Pat Forrester working on clearing the railway for the mobile transporter, the station robotic arm platform.
Atlantis, Houston for EVA.
Go ahead, Megan.
JR, Pat can leave the APFR in its current config if we can just get the current settings, please.
That's great news, Pat, if you could just read them off.
Okay, it's a clocking of 7. Papa Papa. Bravo. 6.
Okay, copy 7, Papa Papa, Bravo 6 for the settings, and we're good to go.
I'm in position to swing this thing around the Foxtrot if they want it.
I'd say just leave it. Let's press with installing the T-handle tool.
All righty.
Houston copies, thanks.
This is Mission Control Houston. Today's spacewalk by Pat Forrester and Steve Swanson, now 4 hours, 39 minutes in duration. Just a look at Steve Swanson on the left and Pat Forrester on the right.
Back toward the work area.
Swanson working with the installation of some local area network cabling for computer systems on the exterior of the Unity module. This is a view from Pat Forrester's helmet camera as he works with the micrometeoroid and orbital debris shield that was removed earlier on the mission by Jim Riley as he was installing a hydrogen vent valve on the outside of the Destiny Laboratory module for the oxygen generation system. Pat Forrester having a look at the panel that was tethered in place when Riley was unable to get its connectors sink back down. He's retrieved from the airlock a T-handle tool that we can see here at the lower portion of your screen that'll be used to try to engage those bolts.
I'm going to get it under these cables, and then we'll try and get the end under down there. Copy. A little bit more. Kind of go slowly. Alright, I'm going to let you get in position up there. Alright. The main thing we got to do is get those ends down, those tabs. Yeah, let me get this right out of the way. Alright, JR, I have got 2 reps. 1 adjustable. I've got the T-handle. And all I think I'm supposed to have. Right? See.
Okay, guys, let's head on towards the lab and let's get that one cinched down, and I think we'll be calling it a day.
Really?
Yep.
Okay.
Goes fast, doesn't it?
Flag, yeah. What's the best way, JR, at this point to go follow Pat, or should I go back to the front side,
Atlantis,
back around to the front and head over?
Go ahead, Megan. DJ, we show Swanee still in the area for the node handrail 120 removal if he has time to get it.
Does he need to come out here to the lab?
Okay, it's totally your call. We'll slow him down. We're just trying to hurry him back inside.
Stand by, Swanee.
And we think just Pat needs to go and work on the vent valve.
Okay, Pat, we're going to send you up to do the vent valve, MMOD, and a valve open, and Swanee. Stand by 1 second.
He could, you know, he's right over there. He could pick up that handrail. Oh, the handrail, yeah.
Yeah, that's what we're talking about. And Swanee, if you want to do that, we'll pick up handrail 120.
Okay,
Oh, my goodness.
This is Mission Control Houston. Steve Swanson and Pat Forrester still outside the International Space Station on their second spacewalk of the mission, the fourth overall spacewalk of the mission. They're unable to get the latches engaged on that micrometeoroid and orbital debris panel on the end of the Unity module.
With 345 inch pounds.
And so tethered it down so that it won't go anyplace and still be available to protect the space station if debris or micrometeoroid were to come at that particular panel.
Atlantis, you have a go.
Outstanding. Okay, first thing up, Pat, open the vent valve for us.
Pat Forrester being instructed to move on to his next task, which is opening the hydrogen vent valve that was installed by Jim Riley earlier on the mission. Clay Anderson and Sonny Williams have been working on installing the plumbing on the inside of the space station so that they can later on in this increment activate the oxygen generation system.
Okay, that is open.
Thank you, sir.
Now, JR, from the picture, I think we're happy with this one. You're probably looking. And then I think this one, they want me to put one more to it and get it inboard under the spitz bag if I can. Would you agree with that?
That is correct, and I think what we want to do is shift from right where your left hand is and across. Yep, we want to come off a handrail 270 right there.
Okay.
Bring it across down to by the spitz, down on the handrail, which is underneath the spitz cable bag, 280.
I agree. They're going to hand those in to you. Okay. Try to get my reel to reel up here.
Now that one's just a little sticky.
Yeah, there it goes. And then I'll take it off of here.
And for the folks on the ground, that's number 28 on the 85. It's been a little bit slow in retraction.
I got him, Pat. All right. There they are. Thank you, Pat. All right, JR, those are handed in.
Okay, I see everything done outside there, Pat, if you concur.
I do.
Okay, it's time for you to come on in.
Okay, I'm taking one last look, and if I could, just say Happy Father's Day. It's been a great way to end it. I want to say Happy Father's Day to my dad, my father-in-law, and for being a father to my two sons, so thanks. Oh, to echo those same ones, thanks, Pat, for reminding me. That's nice. I guess I'll be to my dad and kids, though.
Absolutely. A lot of fathers on this flight, and we're all enjoying a great Father's Day.
and today was the fourth EVA that we had. And here you can see Swanee and Pat briefing with JR and going over some of the last-minute changes to the procedures. This was kind of a procedure that was not planned, obviously not an EVA that we had planned on doing, but the guys are ready for the task. And Oleg Kotov here, you can see him getting the guys secured behind the hatch. And this is the view inside the airlock as we're getting ready to pump down to 10.2 psi, and that's the pressure that we actually will take to our pre-breathe at. Our challenges on orbit is to try and put the gravity's helping you get yourself into the lower torso assembly. But here in space, you really got to wiggle your way into the suits. And once we're in the suits, we go through a variety of checks just to make sure that all the equipment is checked out in proper configuration and ready for the EVA. Inside the suit, it is a rubberized garment which contains allows you to have a pressurization within the suit, and so you have to have comfort gloves in order to make sure that your hands will get rubbed raw as you're working outside. We're really going through the final checks before we get ready to put the guys inside the airlock. There you can see Steve Swanson is ready to go, and Pat Forster, his EV3 is ready to go. There's Pat. As the IV crew member, my responsibility is to make sure that all the necessary procedure steps have been followed to ensure the safety of the EV crew members. Once our 10.2 depress is complete, we have to repressurize the equipment in the crew lock back to 14.7, and this allows us to put the EV crew members into the crew lock and depress the vacuum of space. And here you can see Pat Forster coming out of the airlock.
This was a great spacewalk to be part of. First of all, we were going to go out and finish the task for which 13A came up here, and that's to leave a working solar array for more power for the station. Also, we had a chance to do some tasks that we had done just a little training on, and it's a good chance for us to utilize the skills training that we receive all along. We were able to do some things that will help future spacewalks and to set things up for future spacewalks.
This is Steve Swanson. That was me working on an APFR. I had to relocate that from the DLA work position to the drag-link kill pin work position so that Pat Forster and myself could remove the drag-link kill pin and allow the MT to access all the way down the truss.
One of the things we did was, once again, to put the Sarge in a configuration where they can begin to rotate the solar arrays. And we did that by removing the last remaining launch restraints, doing a little bit more work on the drive lock assemblies. And then once that was done, we gave Houston a go to begin their work on the ground to power it up.
task that we had on this spacewalk was to clear what we call the path for the mobile transporter, and it's a piece of equipment that can move up and down the front face of the truss. The robotic arm can ride on that, and it's a piece, we call it the drag link kill pin. The kill pin is something that helps hold it in the shuttle bay as we bring it up, but once we get it up there, we don't need it anymore. So here we are. We have disconnected it, and we're rotating it into a position on the interior of the truss where it will be stowed.
This is a picture from Pat Forrester's helmet cam, myself, Steve Swanson, while we were working on that drag link kill pin.
The spacewalk is a whole lot more than the two people that are outside. It's an entire team. You've already seen Danny, who got us suited up and out the door safely. Then Jim Riley is inside the orbiter, and he is running through all the procedures and gives us instruction on how to do each task, especially for an EVA like today that is just put together the day before. We haven't really practiced it as a end-to-end spacewalk, and so we depend a lot on him to put us in the right place and give us the instruction that we need. One of the things people enjoy most that we bring back, since everyone didn't get a chance to go up there, are the pictures, and so it's important that we document those, and CJ was just taking some pictures out the window.
Okay, this is Brew Archambault. There was no robotic operations today in support of today's EVA, so during the EVA, while Pat and Swanee were outside doing their deal on EVA 4, myself and Sonny and Daniel Levis and Clay Anderson were helping in some last-minute storage items that were transferring over from the International Space Station to the orbiter. And we're going to get these stowed either today and or tomorrow in preparation for the undock. There was a lot of stuff that came over on the orbiter that went to the space station. We got that taken care of early on in our dock period, and today was the day we were going to pack up a lot of stuff that was coming back with Sonny that's going from the station to the orbiter. And here you can see it. Nice pass from Clay Anderson to Sonny, deflecting them back around to myself, and then from there we'll take it over to the orbiter. From the station, we go down through the PMA into a very dark shuttle airlock. We lights off to conserve some energy, and then back up through the tunnel into the shuttle. And out into a barely lit mid-deck of the Space Shuttle Atlantis.
We had a chance today to translate over to some areas where we hadn't been very often or hadn't spent much time, and one of those is we were trying to connect a cable that runs from the node of the American section over to the Russian segment, and the Russian connector was already out there waiting, so we took a cable out there and made that connection that will help with node inside the station land. also opened the H2 valve that Clay was working on inside and Jim Riley had been working on 2 days ago on his second spacewalk. It's right above the orbiter, so it was a good chance to take a peek in the windows.
After a good EVA, Pat and myself, we came back inside, and as before, Danny was waiting for us to finish up his inside IV job, and he did a wonderful job today.
Here's a shot of Clay finishing up the tools stowage from the H2 vent task, and he did a lot of leak checks and hard work over the last 2 days to make sure that the internal system matched up with what JR did on the external. And of course, Pat's valve throw did that. Here you see Blue and Sonny and Danny going in to get the EV crew out of the airlock once they repressurized it.
And after they get us in, we hook ourselves up, or they hook us up, I should say, to called EDAs, or racks on the wall, which the spacesuits can fit into. That holds us secure while they take the spacesuits, we get out of the spacesuits. And hearty handshake from our commander and a job well done. And here's, again, Pat taking off his LTA. Again, it can be difficult without the help of gravity.
After we got the guys out of the suits, it was time for CJ and I to do a little O2 transfer from the shuttle and help recharge the oxygen tanks on the airlock of the station. And here you see CJ reconnecting some of the lines that connect up to our high-pressure recharge pump called the Orca, located in the top of the airlock here. And here you get a chance to see CJ coming back from the shuttle. One of the best things about being in space is floating in space.
Well, this was our last evening to have if possibly, to have a little celebration with the expedition crew. So we did the traditional hanging of our sticker on the node wall. You can see there's a lot of history there with all the other shuttle missions that have flown up here to the station. This time we put on a different technique, which worked a little better. And there's the station commander, Fyodor, making a few comments about the success of the mission, the recovery of the Russian motion control system, and also the finishing of the 13A task with the S3-S4 segments.
Another tradition we have is our EV1 Jim Riley is hanging the sticker in the airlock. I know it's a great tradition for him because he made the first spacewalk out of there and one of his earlier patches is on. So we do put that sticker inside the airlock and we all get a chance to sign that. It was a lot of fun. And there's CJ signing his name.
after we finished the signing of the patch, then it was time for both crews to join together in the Russian segment. It's a Russian tradition to offer foods to the visiting crews, and we were happy to partake with some of that. It's kind of unique, different foods that we're not used to eating in the American diet, and was all good. I believe I tried moose pate for the first time tonight, so that was delicious. Here we are in the service module, and you can see there's Sonny and Oleg opening up the foods. The crew is very happy to be finished with this mission for as far as the EVA tasks and the major robotics out of the way. And we have just some transfer to finish up, and then we will look forward to winding the mission down here with the undocking and the landing. There's a lot of history in the service module. They have pictures up there from the past missions, and including a picture of Yuri Gagarin, the first human being to fly in space. There's his picture right behind Pat.
So kind of in the Russian tradition, they had a regular feast for us, just a few light snacks as they called it, but it was some terrific food, including the moose pate CJ was talking about. We had olives, and we had some sudak, and also some chicken and cheese, and just about anything you could think of, and had a very nice meal with our Russian colleagues. And those were the highlights for Flight Day 10, and thanks to all the folks on the ground that helped make it possible. We do appreciate it a lot.
Und der vierte und letzte Außeneinsatz während des Besuchs der Raumfähre Atlantis bei der ISS, der war am Ende damit also auch erfolgreich.
Ja, zuvor waren bei der Montage der Sonnensegel ja russische Computer ausgefallen. Guido Schmidt fasst noch einmal die Ereignisse zusammen.
So viel Turbulenzen auf einmal gab es schon lange nicht mehr im All. Am Ende ging eine ereignisreiche Raumfahrtwoche dann aber doch mit einem erfolgreichen Monteureinsatz zu Ende. Beim vierten und letzten Außeneinsatz lief für die Shuttle-Astronauten Patrick Forrester und Stephen Swenson alles nach Plan. Die Klempner im All entfernten eine Antenne, installierten ein Schutzschild gegen Meteoriteneinschläge und beendeten die Arbeit an einem neuen Sonnensegel für die Energieversorgung der Raumstation ISS. Dieses neue Sonnensegel hatte der Besatzung auf der ISS kurzfristig gewaltiges Kopfzerbrechen bereitet. Denn beim Anbringen des Segels kam es zu einer elektrostatischen Entladung, die im russischen Modul die Computer lahmlegte. Die Navigationscomputer sind ausgefallen, wie zwei weitere zentrale Systeme. Unsere russischen Kollegen arbeiten fieberhaft daran, sie wieder zum Laufen zu bringen, bisher ohne Erfolg. Kurzzeitig stand deshalb sogar eine Evakuierung der Station zur Debatte. Dann konnten die russischen Kosmonauten Kotov und Jurchitschin auf der ISS die Rechner aber wieder in Gang bringen. Unterdessen beschäftigten sich die US-Astronauten mit ihrer Atlantis. Eine beschädigte Isoliermatte musste geflickt werden, Heftklammern aus dem Erste-Hilfe-Kasten. Nach dem Okay aus Houston kann es jetzt am Dienstag wieder Richtung Erde gehen. Mit an Bord ist auch die US-Astronautin Sunita Williams, die Frau, die am längsten im Weltall gelebt hat. Gut 193 Tage, wenn sie am Donnerstag hoffentlich wohlbehalten zurückkehrt und wieder festen Boden unter den Füßen haben wird.
Sprechen wir darüber. Bei uns im Studio begrüßen wir Haro Zimmer. Er ist Raumfahrtexperte. Schön, dass Sie da sind. Guten Morgen.
Guten Morgen.
Können wir jetzt wirklich einen Strich unter dieses Kapitel Pleiten, Pech und Pannen auf der ISS machen?
Ich hoffe, aber heute Nachmittag gibt es noch ein ganz entscheidendes, ein wichtiges Experiment. Im Augenblick wird ja die Lageregelung, die Orientierung der Station immer noch mit Hilfe des Shuttles durchgeführt. Wir wissen, die Computer funktionieren. Heute Nachmittag steigt ein Test. Heute übernehmen die Russen wieder die Steuerung. Sie probieren, ob ihre Computer wirklich reagieren und agieren, so wie man es erwartet hat. Aber man geht in Houston und in Moskau natürlich davon aus, dass das perfekt sein wird. Aber alles guckt natürlich ein wenig gespannt. packen die das nun wieder und dann, glaube ich, kann man ganz beruhigt an die Heimreise denken.
Gibt es denn da noch so eine Schocksekunde, dass man sagt, jetzt wird eingeschaltet, oder kann man das nicht so parallel laufen lassen?
Nein, nein, es wird langsam hochgefahren. Es ist weniger das Einschalten, sondern man wird einfach probieren, ob alle Systeme funktionieren, ob die Station wirklich reagiert, so wie sie reagieren soll. Und das wird man also in aller Ruhe tun, denn dafür schließlich sind die Russen verantwortlich. Ich möchte doch nur einen Satz noch dazu sagen, der in der Diskussion ein wenig immer zu kurz kam. Die Elektrizitätsverteilung in dieser Station ist extrem kompliziert. Sie unterscheidet sich im russischen und im amerikanischen Segment. Also da finden eine ganze Reihe von Transformationsprozessen statt, bis der Strom von den Sonnensegeln tatsächlich dahin kommt, wo er hin soll.
Auch von den neuen Sonnensegeln jetzt.
Genau, nicht? Und das ist eine sehr kritische Situation und man hofft jetzt durch gewisse Schaltungen, sie überbrückt zu haben.
Aber macht man sich auch Gedanken unter Umständen darüber, das Ganze anzupassen oder einen Stromkreis zu bilden, der im Prinzip einheitlich ist?
Das hätte man bei der Planung machen sollen, aber es ist tatsächlich so, die Russen haben also ihr System, sie sagen, wir haben 20 Jahre mit der und der Spannung gearbeitet, unsere Instrumente sind darauf eingebaut, die Amerikaner haben sich auf ihre Technologie berufen, man hat aber Schnittstellen gebildet, die sozusagen ein System in das andere wandeln können. Da liegen natürlich immer die Knackpunkte.
Jetzt kann die Atlantis dann wohl auch zurück. Was wurde da, wurde das ernsthaft geflickt oder war das eigentlich nur so eine Notoperation, die vielleicht gar nicht nötig war, zur Sicherheit?
Darüber kann man streiten, aber die NASA lässt natürlich keine Gelegenheit aus, zu zeigen, dass man in der Lage ist, Reparaturen am Hitzeschild, an der Isolierung vorzunehmen. Man hat ja nach dem Columbia-Unglück 2003 so eine Art Reparaturkit, so einen Apothekenkasten mitgenommen mit allen möglichen Dingen. Und das will man einfach mal probieren und ich glaube, Vorsicht ist in dem Fall wirklich die Mutter der Porzellankiste. Man hat gesagt, das Zeug brennt ab, aber sie haben es gepackt und sie haben sogar also das mit diesen Klammern ganz gut zusammengetackert.
Sagt Harald Zimmer, Raumfahrtexperte, zu Gast bei uns im Studio. Vielen Dank.
Bitte.
Bei ihrem 6,5-stündigen Ausflug ins All haben 2 Besatzungsmitglieder der ISS eine neue Drehverbindung für die Sonnensee befestigt. Bei der Montage der Segel war es vor einer Woche zu einem Computerausfall an Bord gekommen. Zwischenzeitlich drohte sogar eine Evakuierung der Station. Morgen soll die Raumfähre Atlantis von der ISS abkoppeln und am Donnerstag auf der Erde landen. Und jetzt zu den Wetteraussichten für Deutschland.
Beendet. Gut 6,5 Stunden brauchten die Astronauten, um eine Drehverbindung für die neuen Sonnensegel an der ISS zu installieren. Die Segel dienen der Energiegewinnung. Ihre Montage am vorigen Montag hatte einen Computerausfall verursacht, der erst nach Tagen behoben werden konnte.
Good morning, Atlantis. That song was for Pat.
Good morning, Shane, and recognize what a blessing it is to be up here in space. I'd like to thank my family for that song and also for you for all your hard work on the ground.
Thanks, Pat. Good to hear your voice.
This morning's wake-up song, entitled Redeemer by Nicole C. Mullen, played for mission specialist Pat Forrester, a day after he completed the second spacewalk, his second spacewalk of the mission, as the crew of Atlantis looks ahead to a morning off duty and looks forward to the last exchanges of supplies with the International Space Station before an anticipated hatch closure this afternoon. Falcon Console in the International Space Station Flight Control Room reports to Flight Director Annette Hasbrook that the starboard Sarge has been taken into the auto-track mode, that at 7:03 Central Time today. This view from a camera on the International Space Station, if you look closely at the lower left portion of the frame where the solar wing moves out of the boundary of the frame, you will be able to see that it is indeed moving. The starboard solar alpha rotary joint on the International Space Station just commanded into the auto track mode and has begun to move and is tracking the sun. This will go on for on and off for a couple of hours this morning as the flight controllers take data on the operation of this new hardware to ensure that it's all installed and operating properly.
Houston, Moscow, and Huntsville on 2. We're going to start the DBC a little bit early because I'm going to start it and Clay's going to finish it, or Clay and Fyodor and Oleg are going to finish it without me.
And Sonny, we're with you in Houston.
Exploration isn't necessarily always logical. It's something that comes from inside each and every one of us. I believe we're all born with this curiosity called exploration. Human spaceflight is just one aspect of exploration, but it's the one that I've been intimately familiar with over the past 6 months. So I feel I can talk to how it affects thousands of people around the world who have worked on and still work on this amazing engineering and science project we call the International Space Station. These folks, along with their families, have dedicated their lives to ensure the success of astronauts and cosmonauts. Spark that curiosity called exploration for the next generation. I'm sad to say goodbye, but that means progress is being made, and it's time for the International Space Station to grow a little more. You, the ISS, will always be a part of me, as you are a part of so many. You will pave the way for our future.
These are views on the outside of the International Space Station showing Canadarm2, the station's robotic arm being maneuvered. This movement of the space station robotic arm under the command of astronaut Clay Anderson along with cosmonaut Oleg Kotov takes the free end of the robotic arm in to grapple onto a fixture on the mobile base system. The arm is operating from the mobile base system with the secured end attached. At the end of this procedure, it will be double grappled onto the mobile base system, this putting it in a position for the end that is currently attached to the mobile base system to detach and walk off to the Destiny laboratory module. That walk-off procedure will be done later this week after Atlantis and her crew have left.
Well, it's been a great mission, but all good things come to an end. We've had a wonderful time up here with the Expedition 15 crew. We swapped out crew members and brought Clay Anderson to your crew, Fyodor. And we take Sunny Williams home. I know you'll miss her. She's a joy to work with, but it's time for her to go back to planet Earth. We're very happy about the success of the installation of the S3, S4 truss, fully operational, and many other tasks were accomplished. We faced some adversity together, but through the joint efforts of our crews and working with our excellent control centers in Houston and in Moscow, the problems were overcome and the mission was a success. Thank you very much.
Thank you very much, CJ2.
The time is very interesting. The time coming too slowly and going too fast. And only 10 days ago we wait launch, shuttle launch, and of course Sunny Williams wait this time very well, yes. 10 days, it's too short time, but very expressive time. And now we can say the shuttle, STS-112 and his and crew, shuttle crew, done very well all tasks. And of course we had some problems, and thank you very much, of course, MCC Houston and MCC Moscow, because everybody on ground worked very hard all days, all nights with us together, because we are one big crew, everybody. And now we would like to say goodbye, shuttle. Have a good, safe landing. Yeah, until we see again, Sunny too, and thank you for Clay.
ISS and Atlantis from your ISS flight control team. We really enjoyed working with you all throughout this docked mission. Fyodor and CJ, your crews have been truly an integrated team. We've been really impressed watching you work together through all the challenges, both planned and unplanned, of the flight. You got all the mission objectives done and then some. Congratulations to all of you.
Thanks a lot, Houston. Great working with you too.
This is Mission Control, Houston. That concludes the farewell ceremonies aboard the International Space Station Outpost as it orbits 211 statute miles over the South Pacific on a northeasterly course toward the coast of California. Commander Rick Sturko of the STS-117 crew speaking for that team, providing his thanks to the Expedition 15 crew and Commander Fyodor Yurchikhin aboard the International Space Station. Sturko indicated that the Atlantis crew had a wonderful time with the Expedition 15 crew. They were happy to swap Clay and Sunny, Clay Anderson and Sunny Williams. That Williams was been a joy to work with, but it's time for her to come back to Earth. He indicated that the team was very happy with the work they accomplished with the delivery and installation of the S3, S4 truss structure and its new solar arrays, that they had faced some adversity together, but working together as a team and with the respective control centers in Houston and Moscow had managed to overcome those and have a successful dock mission. Expedition 15 Commander Yurchikhin indicated that it was a very fast 10 days for him, but that the shuttle crew did all of its work very well. He thanked them for their help with the problems and thanked everyone on the ground for working day and night to support the space station. And finally, he said thank you for delivering Clay Anderson to the International Space Station. Clay will remain on board with Yurchikhin and Oleg Kotov as they continue their activities in orbit.
Okay, here's the beginning of the day today. One of the things we did is Brew and I maneuvered the entire stack, and then we performed a wastewater dump with Swanee's assistance. The switches are pretty much spread all over the flight deck and the mid deck of the orbiter.
and it's a little hectic and has to be done properly to coordinate the maneuver and then the two different dumps, the SIMO dump like that, but not a big deal. We practiced it in the sim, and in coordination with our ground control team, we were all set to do this task. Here's Swanee shooting to get the correct wastewater dump valve open, and then we'll show out the side hatch window what it actually looked like. You see Brew and Swanee looking out the window now, checking it. Not sure how much justice the video is doing, but it looks kind of like snow when you see it. This may be a better view out window one of the flight deck.
And with us closing the hatches tonight, we're last-minute packing and transfers were going on pretty much all day long. And here you see Pat hauling in some of the equipment and helping me out with inventorying some of the stuff going into the big bags. And we coordinated all of that with Sonny. And here's Sonny's dedication in the morning.
That was a tough day today to know that I was leaving the station for the last day on station, but also very exciting to become part of the Atlantis crew and get ready to come home.
Part of the transfer had to do with getting all of the equipment that we'd use for the 4 spacewalks. Some of that belonged on station, and of course we brought up some of it, and just getting it divided up and putting it in the right place took a while.
One of the tasks we also had today was take down the IWIS sensor and accelerometers that are used to measure certain accelerations on the station and shuttle.
Yep, we'd finished transferring some oxygen from the shuttle over to the station using the Orca pump you see there. Then we had to reconfigure the cooling and the hoses. This is a view of us taking samples that have been taken for science over the 6-month increment out of the Melfi, which is the freezer we have, minus 80 degrees freezer. And we have to do it pretty quickly because there's a time limit to ensure the temperature of the samples, then they stay frozen, as well as the Melfi itself. And I'm handing the samples off to Clay Anderson, who's putting them in a cold bag, and that's how they'll stay. Essentially, it's a cooler. They'll stay in that cold bag until we get home, so then the scientists can take a look at the science. You might notice that Clay and I have on white gloves, and that's because of the temperature, and so nobody else there can touch these pieces of equipment because it's so cold. You need to have those safety gloves on. All right, so we're back doing more O2 transfer. Like I said, Pat and I are deconfiguring the high-pressure O2 transfer hoses and the electrical power for the Orca pump. An O2 transfer is a critical operation because of the high pressures. The oxygen is can cause rapid combustion, so we're very careful with that. We wear surgeon's gloves, and we change them, powder-free gloves, change them frequently, and make sure everything's capped and inspected before we make the connectors.
myself, we're just helping JR out, who's our mid-deck captain and transfer officer all day long as he organized the mid-deck receiving the last of what was coming over from space station. The last little bit of transfer that we had was basically taking over the EMUs, which we had brought over from the space shuttle. These are the ones that Jim Riley and myself had used during our two spacewalks.
Well, after all that, it was time to say goodbye to the crew of Expedition 15 and head on back to planet Earth. We still got a couple days to go, but an important part was closing out the hatches after we'd said our farewells.
One of the last couple things that Clay and I had to do for handover was switch our American flags as the American presence on station, and then switch our Expedition 15 patches. The initial patch had my name on it, and this patch now has Clay's name, so he's officially part of Expedition 15. You can probably see it's a little bit dark, but that's Fyodor and CJ shaking hands as the hatch is getting ready to close. And that's our last activity with the station for this evening.
As part of our regular maintenance on the space shuttle, we change out the lithium hydroxide canisters, which scrub the CO2 out of the air and keep the atmosphere a habitable one here on the space shuttle. And so this is a change out which occurs every day per prescribed instructions from the ground. You can see here the task is not a simple one. It's definitely something that requires teamwork.